Hello and welcome back to this course of videos on MongoDB NoSQL database. Now up until now our shoestore Mongo database has contained only one single collection called customers. Now our customers collection here has a very large amount of data, including reviews and email addresses and orders, and in order to store the same data on the relational side in our MySQL database, we've actually had to create 4 separate tables. Now, to remind you of the reason for that, so if we look at, for our simple key value pairs that have primitive data types, strings and integers, that's fine. We stored that in our customers table here on the relational side. However, when we move to email addresses is an array data type. And of course, on the MySQL side, the relational databases don't support array data types. So to avoid having to add email address here and duplicating these rows and causing redundancy, we created a completely separate table for customer email addresses and can reference back to the customers table using this customer ID field, which maps back to the ID field on the customers table. Similar with reviews. Review also has an array data type, this time with embedded objects, but the same result on the relational SQL side is we had to create a completely separate table, customer ID field, which references back to the ID field in the customers table. And finally, exactly the same thing with orders. Array is the data type. This array holds multiple embedded objects. Each embedded object has a number of key value pairs, and on the MySQL relational side, we had to create a completely separate table. In this one, this field here, this customer ID field, is referencing back to the primary key ID field on the customers table. And just to remind you, these fields, this field here is known as the foreign key. The foreign key on the child table links back to the primary key on the parent table. So it's excellent that we're able to avoid creating all these separate tables in Mongo, creating separate collections. We're able to avoid that by using these embedded objects, embedding these objects within arrays. That's fantastic. However, there are sometimes certain instances where you wouldn't embed, and instead you would take the approach of the relational databases, of normalization, and create a separate collection. Now, the kind of circumstance, I'm going to give you an example of a circumstance where I would create a separate collection. So I have seller ID here, but instead of, let's say I didn't want just seller ID, I wanted a lot of information about the seller that sold this particular product, that sold the product for this order. So let's say I wanted the seller name and I wanted the seller tier, so the rating that this seller was given. So if I was embedding, I would put seller would be my key, and then I would have an array here. This would be an array with 3 embedded objects, which would be ID of the seller, and the next object would be the name of the seller, and the next object would be the tier of the seller. Now, the reason that I have decided, instead of doing that, is I'm going to create a completely separate sellers table, is because this key value pair here, this field seller tier, can change. Now, we may decide that Rickshaw Tiger Heads has improved their performance and we're going to increase them from a tier 1 to a tier 2. Or Vortex Galesh have been performing particularly well, so we're going to increase their tier from a tier 2 to a tier 3. Now, if all of this information was embedded, if the seller tier was embedded in an array here within the orders array, every time that we did want to, let's say, increase the tier of rickshaw from tier 1 to tier 2, we'd have to go through every single document and within every single document, every single orders array, and look for where the seller was actually rickshaw, and then we would need to change in each individual value we would need to change. So that's going to be very time intensive and very complex for Mongo to have to go through each individual array for orders and check every single one, check every single order to find the rickshaw seller. However, if we put it in a separate collection, we would just need to make the update in one single place. So you see, what we have here then is we have similar to on the MySQL side, where we have the ID in the customers table, and then on the emails table, what we call the child table, we have a foreign key here which links back. We're doing the same thing here in MongoDB. So here I'm just putting my reference here. This is my foreign key, if you like, my seller ID in orders, and I go to my seller's table, and that primary key is there. So seller ID of 2 is the foreign key. ID primary key here of 2 is the primary key. So this is the circumstances where you don't embed is where the object that you're going to embed has to be updated frequently. And like I said, in our case, sellers could move between tiers all the time, and we don't want to have to be drilling right down into these sub-objects to find out what the seller ID is and whether we actually need to update it or not. So I hope this gives you some good insight into when to normalize with NoSQL databases and when not to. And the next video we'll be looking at querying with joins. Joins would be when we query across our MySQL relational database, and querying across 2 different collections in MongoDB we'll be doing via referencing. So I look forward to seeing you in the next video.